All right, so now we've learned about the location of electrons, but we're going to talk a little bit more about how electrons interact with each other. So we're going to focus on the 3 electron rules. Rules you need to follow in determining the location and orientation of electrons. So we're going to talk about the Aufbau principle, Hund's rule, and the Pauli exclusion principle. So here are the 3 electron rules. So we talked about an electron orbital diagram. How do you know where to put the arrows? And how do you know what order to put the arrows? Well, let's start with the first rule. The Aufbau principle is German for building up. And basically what it says is always start at the lowest energy level first and then work your way up to higher ones. So electrons are always going to want to go in as close to the nucleus as they can. And then only when those spaces are full do they move to the next higher energy level and you work your way up from there. Electrons being negatively charged are attracted to the positive charge of the nucleus, so they want to get as close as they can be. So you always start at the lowest energy level first. So as you take a look at this, we have this stacked electron orbital diagram, which is basically showing the distance to the nucleus. So here you can think of, here's the nucleus. And as we are thinking about the electrons, first thing you want to do is look at a periodic table and figure out how many electrons or how many arrows are we going to have to draw. So if we look at sulfur, I'm going to look back here at mine real quick. There are 16 electrons for sulfur, so we're going to add 16 arrows. So as we look at this stacked electron orbital diagram, the first 2 are going to go right here in the 1s orbital. It's the closest to the nucleus. But it can only hold 2, so we're going to have to jump up to the next one. So Aufbau says start at 1s2, go to the next one, 2s2. We're going to jump to the next one, and we're going to go to the 2p's, and we can add up to 6 there. That gets us to 10. Then that's full, so we jump up to the next one, which is 3s. Once that's full, we've got 4 left to fill in, so we're going to jump up to the 3p, and we're going to put in our 4 electrons in the p orbital. So you always start at the bottom and you work your way up. That is how the Aufbau principle works. You don't start filling in the D's or the S's up here. You don't want to do that because they are too high. We've got to start lower and work our way up from there. Rule number 2 is Hund's rule. And what Hund's rule says is that because electrons repel each other, they want to be as far away from each other as they can when they're in the same energy level or the same orbital or same suborbital. So they will always go in unpaired first before they have to pair up. One way of looking at it is look at nitrogen, which has 7 electrons. Well, the Aufbau principle says we got to fill in 1s first. We fill that in. Then we have to go to the 2s next because of the Aufbau principle, so we're going to fill in those 2. But when we get to the 2p, we've got 3 electrons that are left to fill in, but we have 3 places to put them. Because they want to stay away from each other, they are going to go in 1, 1, and 1. They are not going to pair up if they don't have to. Now, I like to think of the Hund's rule like this example. Imagine you're getting on a bus, and it's mostly empty, and you see this guy on the bus. Are you going to, with all the choices of seats on the bus, go and sit right next to this creepy guy? Or are you going to go find yourself another seat? Are you going to pair up or go unpaired to begin with? Naturally, humans go single first. We go before we pair up. So as you're getting on the bus, you're going to sit individually in those paired seats and only pair up when you run out of places that you could go individually. So once there's one person in each set of 2 seats, then we're forced to begin pairing up. So that's Hund's rule. Electrons want to stay as far away from each other as they can, and only when they've run out of places they can go do they then begin pairing up. So as we look at this example of oxygen, you'll notice that oxygen having 8 electrons, it has run out, that 8th electron has run out of places it could sit individually, so now it's forced to begin pairing up. So this electron here has paired up only because now there's no other place it can go. Okay, the other thing that we do is we talk about what's called electron spin, and it's a description of how electrons behave. They don't literally spin like a ball, but they do have these properties that basically say that when they do have to pair up, they have to be spinning in opposite directions. And the way we represent the spin of an electron is the arrows, up and down. So when they are forced to be in the same orbital, they must have opposite spins. We show that as arrow up and arrow down. When they are not paired up, we show them having the same spin, and we represent that with arrow up first. So you put your first arrows in all up, and then as we begin pairing them up, we start to put the second arrow in pointing down. So that's the third rule. That's called the Pauli exclusion principle. So the Pauli exclusion principle states that no two electrons can be exactly in the same place at the same time doing the same thing. That would be like you getting on a bus and sitting on the lap of someone else when there are other seats available. You can't be in the same place at the same time doing the same thing. So the Aufbau principle says you start at the lowest energy level and you work your way up to higher and higher. You start at 1s, then you go to 2s, then you go to 2p. Hund's rule says that if given a choice at the same energy level, you want to spread out. So you're going to go 1, 2, 3, and only when you have no other places to go do you then pair up. Pauli exclusion principle says if you do have to pair up, you need to be going in opposite spins, or show your arrows going in opposite directions. Okay, let's do a little test for knowledge. I want you to get out your periodic table, and which of these properly shows the electron orbital diagram for silicon? So pause the video, take a look at silicon, and figure out which one is correct. Silicon has 14 electrons, so there should be 14 arrows, and the one with 14 arrows is letter E. All right, now we're going to fill in the electron orbital diagram for neon. So we're going to use our electron rules to figure out what neon should be. So the first thing you want to do is find neon on your periodic table, and neon is number 10. So we're going to need 10 arrows. So the first thing you're going to do is follow the Aufbau principle. We're going to start at 1s and work our way up. So here's our first arrow. And because of the Aufbau principle, we can't jump up, so we're going to have to pair up the 1s. So the Pauli exclusion principle says if they've got to go in the same orbital, they have to have opposite spins. So one arrow up, one arrow down. The Aufbau principle then says let's jump up to 2s. Put in our first arrow. We can't jump up to the 2p yet, so we're going to have to pair up the 2s. Pauli exclusion principle says put in the arrow down. As we move to the 2p, we're going to jump using the Aufbau principle, but the Hund's rule says before we add in that next electron, we need to spread out. So the next electron is going to go to a different suborbital. Maybe instead of the x suborbital, it's going to go to the y. And the next electron is going to go to the z. So they're going to go individually first before they pair up. So that's Hund's rule. But now, as we move to the next electron, there's no other places for it to go, which means they're going to have to pair up, and Pauli exclusion principle says add the opposite arrows. Then we go to the next one, then we go to the next one. And now we have the electron orbital diagram for neon with 10 arrows. All right, let's try again for potassium. Now, potassium is number 19 on the periodic table, so we're going to need to do 19 electrons, 19 arrows. So one thing you'll notice is the pattern keeps repeating itself when you get bigger and bigger. So we're going to go in here and add our first 10 to match up with neon. You'll notice that we're going to fill it in the same order that we filled it in before. In the 2p, we're going to go unpaired, and then we're going to start to pair up in opposite arrows. Now we've got 10. Aufbau principle says, let's jump to the 3s, pair them up. Now we're going to go to the 3p. Hund's rule says, let's spread them out. And now let's begin pairing them up again. At this stage, we have 18 arrows, which is the equivalent of looking at argon on the periodic table. But we need 19, so we need to add one more electron. Well, it's important to realize with the Aufbau principle that you go to the lowest possible energy level. And even though 4s is further from the nucleus, it's a little bit lower in energy level, 4s is, than 3d. And we haven't talked much about 3d, but realize on here that 4s is below 3d. So that final electron is going to go in the 4s. And as you look on the periodic table, you will notice that potassium is the first element in the fourth row in the s block. So that electron configuration ends with 4s1, which is exactly where it's located in the periodic table. So the idea of the periodic table is it's designed to match up with the location of the electrons and should match up with the electron orbital diagram. All right, finally, let's finish off by going to chromium. So chromium is number 24 on the periodic table. So we're going to keep working our way across that row. And so after potassium, we go to calcium. Now we move to scandium, number 21. The next highest energy level is actually 3D. So we're going to put in our arrow here for 3D. And as we work our way toward chromium, we go titanium, vanadium, and we finish with chromium. Notice Hund's rule says put them in different suborbitals, all arrows up. Only when you have filled up all of those with one arrow do you start pairing up again. So this would be the electron orbital diagram for chromium. And so that's why the periodic table is set up the way it is. It's designed to build up using the Aufbau principle, and so you can actually figure out every individual element, where it's located, and where all of its electrons are located, and at what orbitals and suborbitals, and where the arrows are. So the periodic table is full of all sorts of information about where the electrons are located.